And now I want to introduce Nir Alfasi, my new friend and colleague from Quantum Machines, to tell you a little bit, if I can find his presentation, about the Israel National Quantum Computing Initiative. What happened to your slide there? It's PowerPoint, isn't it? PowerPoint. And where is the PowerPoint presentation? Hold on a second. Where did it go? Akiva, where did I put it? We're looking for Nir's PowerPoint presentation. QCC? QMQCC? 5 minutes, it says? I don't believe you. It must be a quantum computing presentation. It's really fast. That's why it's 5 minutes. So with that, I'll turn it over to Nir. Good luck with the clicker.
Should work?
Yeah, it should work.
Okay, hi. So yeah, I will just briefly introduce the company and the quantum computing center that we're building. So I'm Nir Alfasi, and thank you, Stephen, for allowing me to speak here for a few minutes.
Thank you for sponsoring our conference.
Sure. Yeah, came out of my pocket.
Okay.
Yeah, so I'm going to give you a brief introduction to two things. First of all, the company Quantum Machines, and second of all, the Quantum Computing Center, which we're building these days and scheduled to open by the end of the year. So Quantum Machines is basically the largest quantum related company in Israel, quite by far. It is the world's, we produce the world's most advanced system for control and operation of quantum processors. We have over 150 employees, around 100 of them in Israel. We have over 200 customers worldwide in every university and every company you can imagine. And we believe, so as you probably know, our goal is to accelerate quantum computing. And as Stephen mentioned, quantum computing is not yet applicable. So we believe the way forward is by using hybrid classical quantum algorithms, as Stephen just talked. And these are early candidates for application. So basically, when everyone are trying to show advantage, supremacy, utility, all these words, basically they're trying to find something which someone cares about, right? That quantum computers can do better than classical computers. And we believe that the way to go forward is the hybrid way. And Stephen already took my slides away, but because we already discussed it. But basically, a hybrid. What is an hybrid algorithm? So let's assume that we have a quantum processor, and we run some gates on it or some calculation or estimated cost function. And since quantum computers are not fault tolerant, we have to do it many times and repeat this measurement. And this is where QM shines. Basically, our control makes it extremely fast. It can compute things in real time and makes this part run in minimal time with low latency. But then we have to add also the classical part. And yeah, you're right, this is not working. But a classical optimizer to iteratively find the optimal parameters. And then you have to go into some kind of classical system and compute. And here you also want to lower the latency. And the goal here is to basically produce a hybrid quantum classical system that combines a QPU with GPU, CPU, etc. So yeah, examples, Stephen just talked about variational algorithms such as BQE and QAOA. So for that, this is one of the goals in the upcoming quantum computing center. So the Israel Innovation Authority has chosen Quantum Machines to lead the building of this center. It is scheduled to open around January 2024, maybe earlier, hopefully earlier, next to Tel Aviv University. And the idea there is that this is going to be the first center worldwide to have quantum HPC hybrid center. Okay, it's going to span 5 platforms. 3 of them are quantum computers. Also, Stephen mentioned a few. So superconducting, we're going to have superconducting quantum processor, a neutral atoms quantum processor, and a photonics quantum processor. And all of them are integrated with our control system, our control solution, and also integrated to a high performance computing cluster. So this is, at least at the beginning, it's going to be a hybrid. HPC center, so some of it will be on premise. We're going to have a few GPUs from NVIDIA and also on the cloud. And the idea is that the user can log in online and run his algorithms on a QPU. So basically, you go into your HPC resource list, and then you have, okay, GPU, CPU, TPU, whatever you want, and then you have also a QPU. So this is an addition. You can look at it from, if you're looking from the HPC side, this is, so you get an extra QPU. From the quantum side, you get stronger classical power. And as part of it, I don't know if many of you heard, but we announced a collaboration with NVIDIA. So we're going to combine our control solution, which is called the OPX, with NVIDIA's new Grace Hopper. And this is going to be integrated, and the Quantum Computing Center is going to be the first place in the world to exhibit this amazing solution. And we hope this will put Israel at the forefront of this hybrid quantum classical computing. So we're looking for collaborations and users, basically, if the slide will move forward. Yeah, so you can feel free to contact me. Also, Stephen mentioned some education, so this is also part, I took it out of the slide, but it's also part of the Quantum Computing Center, basically educating the Israeli academia and industry about the quantum computing and quantum computing platforms that are available. So thank you very much.
Thank you very much.